the class. Okay, I have recorded. Okay, let me share my screen, then we will learn about the TensorFlow. Okay, we will learn about the basic of TensorFlow. Like I was mentioning before, the TensorFlow is the framework for building a deep learning model. So if you want to build a deep learning model using Python programming language, so TensorFlow is very useful for us, and we don't need to create the model from scratch. But before we go deep, we go far to build a deep learning model. So we need to understand about the TensorFlow basic. I will give the name as 2021 ST DSAI TensorFlow basic. So actually TensorFlow is similar with NumPy. You know NumPy? NumPy is the library from scikit-learn, not scikit-learn. Yeah, NumPy is a library in Python programming language that can be used for creating a vector or a matrix, right? TensorFlow also have, also it's like NumPy. We can create a vector, we can also create a matrix using TensorFlow. But if we use TensorFlow, there are other functions that we will not get from NumPy, because TensorFlow is used for building a deep learning model. We know that deep learning have a lot of parameters, right? So for example, if you want to build a image classification model, we know that we will use all of the pixel of that image, right? For example, we want to build image classification model, and our image has a resolution 100 × 100, right? And the image also have a 3 channel, because we will build image classification model in color image. Then we know that our model will receive the inputs from the image, and we know that the image is a matrix, right? It's not a 2-dimensional matrix, but 3-dimensional matrix. And by using the TensorFlow, we can create a variable that have n dimension, not only 2 dimension. We know that 0 dimension is a scalar. If we just typing a equal 5, it means we have a scalar variable. But if we create a vector variable, it's like 1, 2, 3, and 4. So it means a is a vector. But if we also can create another matrix variable, it's like if we have 2 × 4, 2 × 4 matrix, it's like this. So we have 2 × 4. We have 2 rows and 4 columns. So we have a 2-dimensional matrix. But if we talk about the TensorFlow, if we talk about the tensor is n-dimension matrix. If we have 3-dimensional matrix, 4-dimensional matrix, and n-dimensional matrix, so we call it as a tensor, not a vector, not a matrix, not a scalar, but a tensor, n-dimensional matrix. And deep learning model, we know if we build a deep learning model, we will have a lot of layers. You know, the differences between deep learning and artificial neural network is the number of the layer. If we have a lot of layer, then we will have a variable, a tensor variable. So yeah, to bring a lot of value in each layer. One layer have more than 1 neuron. If we have n neuron and m layer, so we will have m × n matrix, right? And we don't know. It depends on the model that we will build. If we have more complex model, so our dimension, our tensor dimension will be increasing, right? So the TensorFlow actually, yeah, TensorFlow, it means this framework will provide a lot of function to build a deep learning model, because it can receive n-dimensional metric as an input for a training process and also testing process. Okay, we will start from how to create a tensor variable. So I will create a variable, a tensor variable. So yeah, before we create a tensor variable, we need to import the library, right? So you can just type import TensorFlow STF. So it means we will use a TensorFlow library and we will give the alias as a TF. So this one is for creating, oh no, this one is for importing the TensorFlow library. Then if we want to create a tensor variable, so I will create a variable and I will give the name as a z equal tf dot constant. Then inside this I will create an array, one-dimensional matrix, or we can call it as a vector. So I will give the value as 1, 2, 3, and 4. Then I will print this z variable. Okay. tf.constant with, oh, I forgot to give another square bracket inside this parameter. So yeah, this one. So double square. Wait, let me check.
Double.
Oh, double
Sama dengan
equal.
Pak.
So yeah, double equal. Okay, so we don't need to give another square bracket, right? So yeah, so if we want to create a tensor variable, so actually tensor is a n-dimensional matrix. If we talk about the n-dimensional matrix, so we will also can use the tensor variable to bring a vector, right? So the f dot constant 1, 2, 3, and 4. So it means I have a vector variable, but we can just use the TensorFlow to get the vector variable. As you can see like here, we have a shape 4. It means we have one-dimensional matrix which has a 4 column, right? So what about if I give another variable? So for example, I will create another variable. I will create a y variable, y equal tf dot constant. Then inside this function, I will create a two-dimensional vector. So it means I will give the number for the first row as a 1 and 2, and for the second row, I will give 3 and 4. Wait. Okay. I just want to code like this. So 1, 2, 3, and 4. 1, 2, 3, 4. We have two vector inside the y variable. So it means I have a 2 times 2-dimensional matrix, right? So let me print the y variable like this one. Okay. Wait. Okay, I forgot to give another bracket. So actually, if we want to create a matrix, yeah, not a vector, so don't forget to give another bracket inside this function. So it means I have 2 times 2-dimensional matrix. Yeah, as you can see right here, 2 times 2. The shape of this y variable is 2 times 2. What about if I give another column like this one? 3, 4, and 5. So it means I have 2 times 3. So it starts from the row first, then the column. I have a 2 rows and 3 columns, right? So it means I have the shape of this y variable as a 2 times 3. Then if we create another variable, not another variable, not another value like here. So I will give value as a 6, 7, and 8. So it will change to the 3 times 3. Yeah, 3 times 3 dimensional matrix like this one. So it's actually, yeah, we can create a matrix using the TensorFlow. So the question is, can we use the NumPy to create a matrix? Yeah, so the answer, yes, we can. But if we focusing to build a deep learning model, so we will use the TensorFlow for creating the matrix and also the vector. Okay, so yeah, if I want to print only, the first column of each row. So it means I want to print 1, 3, and 6, right? 1, 3, and 6. 1, 3, and 6 is located at the 0 column. We have a 0, 1, and 3 column and 0, 1, and 3 rows. Then if we want only to print the first column of each row, so we can just type like this. We will get all of the rows in 0 column. So 1, 3, and 6, right? What about if I want only print the first column, the column 1, 2, 4, and 7. So I will just change to 1 like this. 2, 4, and 7. Right. So what about if I want to print only first column 1, 2, and 3, right? So we can just change the row as a 0 and all of the column. I want to print all of the column. So we have 1, 2, and 3, right? So it's very simple, right? If we have a 2-dimensional matrix, what about if we increase the dimension of this matrix? So we call as a tensor, like I was mentioning before. We have more than 2-dimensional, right? So I will create another variable. So I will create x variable equal to f the constant. Then I will give the value of this variable as a 3-dimensional matrix, not 3 times 3. 3 times 3, it means we have only 2-dimensional matrix. But if we have more than 2-dimensional matrix, we call it as a tensor. So I just want copying this value. So I will give another square bracket inside this function. So like this one. So inside this bracket, I will give this value. So it means I have, wait, I will finish the code first. Then we give another square bracket right here. So can you, do you know what is the dimension of this x variable? Anyone can answer my question? How many dimension of this x variable? How many dimension of this x variable, like this one? We know that this one, the y variable is 3 times 3. The shape is 3 times 3. What about this one? What is the shape of the this variable X? Anyone can answer my question? How many? What is the shape? Oh, what is the shape of this X variable?
2, 3, 3.
Okay, so 2, 3, and 3. 2, 3, and 3.
Yes.
2, 3, and 3. Okay. Okay. Let me print this X variable. 2, 3, and 3. Yeah, right. Correct. So what about if I give another variable inside this? So yeah, I will create another variable. So I will give the name as a R variable, A variable equal. So I will copy all of this code. Then I will give another square bracket inside this one. Inside this one, I will give another bracket. Right? Don't be confused, yeah. Okay. What about this one? This one is 4-dimensional matrix. How many? What is the shape of this A variable? Again, don't be confused, yeah. Anyone can answer? 2 times 2 times 3 and times 3. Correct. Yeah. Two times 2 times 2 and 3. Yeah. So this one is the basic of the tensor variable using TensorFlow, right? So if we want to, yeah, if I want, so anyone can maybe can answer my question. If I want only to print the first column, only the first column of each, yeah, of each matrix inside the A variable. So what is the code? So let me copy this code to your to the chat box, so you can just experimenting in your Google Colab. Then my question is, if I want only to get, if I want only to print only this value 136 136 136 136. So what is the code to print that one? Okay, 136 136 and 136. Okay, you can just copy my code to your Google Colab notebooks. Then you can try how to print only the first column of each matrix inside the A variable. 136 136. Okay, I will give you 5 minutes, yeah. So yeah, to think about the code, how to only print the first column of each matrix. Okay, let me pause the screen first. Okay, I get the answer from Fania. Okay, let me check. Okay, let me copy your code, Fania. Okay, right. So we will only print the first column of each matrix, right? So this one is the, yeah, we have 2 times 2 times 3 and times 3. So it means I will only print the first column of each matrix. So it means if I give the 0 variable inside this square bracket in the last dimension, so it means we will get the first column of each matrix, right? Okay, thank you for your answer. So what about if I want only to print 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3? Anyone can answer my question? Only print 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, that one, yeah, I think you have understand about the basic TensorFlow, right? So it's very important for you to understand how to access each value inside your tensor variable. So it means if we know the basic of the tensor, how to access each value inside the tensor variable, so you will be more easy to build a deep learning model. Okay, let me copy the code from Jeremy Owen or Nikki. So I will just copying my your code inside my text code cell. Okay, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, thank you for your answer. So I will note your name. Yeah, don't worry, you will get additional score because you have been actively, yeah, you have been actively answer my question. So Fania and Henry and Nikki. Okay, Vincent and Kenneth. Vincent and Kenneth. Okay. Okay, I think yeah, that's enough for learning the basic of the TensorFlow. So we will start to create a deep learning model. Actually, if you want to explore more about the TensorFlow, I have uploaded the module, yeah, from the Huawei LMS. You can just download from the ULS. Then you can just exploring more about the TensorFlow, how to create a tensor, and how to create a 0 tensor, and how to create a 1 tensor, and also in that module also have some experiment in, yeah, there are not only 4-dimensional matrix, but also there are 6 until 7, if I'm not mistaken, 6 until 7-dimensional matrix. Then you can try it by yourself after this, because yeah, we have limited time to try all of this code inside that module. So we can just move on to the next material. So we will create a very simple deep learning model for classifying the image, right? So I will start to, yeah, I will create another notebook file. Then I will try to build a very simple artificial neural network model to, yeah, to classifying the image. So actually, like I was mentioning before, we can use the CNN, convolutional neural network, for classifying the image, because the CNN is very good, CNN have a good performance to classifying the image because it has the convolutional layer. So actually we will build a CNN. Yeah, we will create a CNN model, not ANN, but CNN, convolutional neural network model, to classifying the image, because our data set is image, not a text, not a label, not the Excel, not the CSV file, but our data set is an image. Then we want to build a deep learning model for classifying the image. We know classification is a supervised problem, right? Supervised problem. So we need to train our model first. Then after that, we can use that model to classifying the image. Then we will try to split our data set into the training data set and also the testing data set. Okay. Okay, let me start to build a CNN model. Wait. We'll try to find the data set first. What kind of data set that we will to classify? Okay. We will use the data set from the Keras library. So actually Keras and TensorFlow, yeah, is the combination, is the best combination library or framework to building a deep learning model. Without Keras dataset, without Keras dataset, we will not be able to create a deep learning model. So actually, yeah, I will start to building a CNN model 2021. Okay. Then, like I was mentioning before, we will use the Keras library. So actually Keras is also, it's like a TensorFlow. We will use the Keras also to build a deep learning model, but inside the Keras variable, we can also import the data set. So actually MNIST dataset is very popular dataset for learning the image classification model, to build an image classification model. So I will give you the description about the MNIST. So actually MNIST is the handwritten digit image. Then we will build a deep learning model for classifying the handwritten digit image like this one. So yeah, MNIST handwritten digit database is created by the Yan Lei Chun. You know, Yan Lei Chun is the father of the CNN model, because this person is the inventor of the CNN. The inventor of the CNN is the Yan Lei Chun. Then we know this person also built a public data set. Yeah, if you watch the tutorial in YouTube how to create a CNN model, so MNIST is a very popular data set for for learning the basic of the CNN. Okay, let me import the data set from the Keras. So we will use the MNIST dataset, handwritten digit dataset. Then we will try to use this dataset to build a deep learning model for classifying the handwriting digit image. Okay, so I will also import the TensorFlow. So like this one. So from TensorFlow, import Keras like this one. So if we want to call the Keras library, first we need to import the Keras library from TensorFlow framework. Okay. Then after that, we will split our data set into two split. Yeah. The first split is for training, and the second split is for testing. So I will just give the name of this variable as xtrain full, gtrain full. Why I give the full word, I will explain it in a second. Then we will also, this one is for training and this one is for testing. Then x test and also y underscore test. If you take the machine learning course, you know we can use the library from scikit-learn for splitting automatically our data set using train test split, right? Train test split library function is for splitting our data set into two split, training data set and also testing data set. But actually, we will not use the train test split function because if we call the mnist dot load underscore data, it means our data will be automatically divided into two split. So we don't need to split it using train test model, a train test split, right? So this one will automatically receive the dataset from MNIST library, MNIST dataset from the Keras library. So it means X-train and X-train and Y-train will contain the training dataset, and this one X-test and Y-test will contain the testing dataset. So let me print the dimension of each variable. So for example, I want to know the shape of this data set. If I'm not mistaken, it contains around 70,100, yeah, 70,100 image. We know that if we call the mnist.load data, so we will have a two type of dataset, training dataset and testing dataset. And we know the dimension of the xtrain underscore full, the shape is 60,000 times 28 times 28. So it means we will have 28 times 28 image. So the pixel of this image is 28 times 28, and we have 60,000 images, right? It's this one is for the training dataset. What about if I change this one into y? X test, yeah, not y but x test dot shape. So we will know the shape of this dataset. 10,000. So it means we will have 60,000 dataset for training, and we will have 10,000 dataset for testing. So I will give the comment below this code. So 60,000 dataset for training, and also 10,000 dataset for testing. So ideally, we will not only have two split of dataset. Ideally, we will have three split of dataset. We must have training dataset, testing dataset, and the last one is the validation dataset. So it means validation dataset is for, it's for, what is it called? It's for validating our model before we go into the testing process. When we train our model, when we train our model, then we will validate the model using the validation dataset. Okay, so if I just give the analogy or the shape of the training, testing, and the training, testing, and validation dataset. So like this one with so if I have, for example, I have 70,000 total data set, right? Because we have 60,000 for training and 10,000 for testing. Then we will split it into two types of data set. For example, this one I will give 70,000, not 70,000, but 10,000 for testing. 10,000 for testing. Then 60,000 for testing, right? So this one is 60,000. But if we want to create another split validation data set, so we will take the portion from the training data set. So for example, I will use 5,000 from the training data set for validation data set. So it means I will give another portion, portion in this location. So for example, I will give 5,000 for validation data set. Now, for validation, and we know that 60,000 for training data set, as we will subtract the training data set by 5,000, then we will have 55,000 for training data set. Then when we train our model, we will use the 55,000 training data set, and in the training process, we will also validating our model using 5,000 dataset. This one is validation dataset. Yeah, from this code, we will only we still only have 2 split of dataset, right? 60,000 for training and 10,000 for testing. Then we will create a validation dataset. So how to create a validation dataset? Yeah, it's very easy. We can just use our training data set with X. I will give the name as X valid and with X valid and also X train with okay. Yeah, X valid, it means I will get the portion from the training data set. So I will explain you in a second. X valid, X train equal X train full, because we have the X train full. So the X train full contains 60,000 data set, right? But I will only get the last 5,000 data from the training data set. So it means I will get only 5,000 from the training data set. The last 5,000, right? For the X valid. So it means this one is the X valid, the validation data set, and this one is the X train. So you know that if we use the image as a data set, each pixel will have 0 to 255 range. The pixel range is from 0 to 255, but I want to change the range from the 0 to 255 into 0 to 1. So it's very easy. We can just divide it, this variable, by 255, right? Then, yeah, this one is for X valid. What about the X train? So the X train, yeah, we can just use the X train full again, but we will get the 55,000. Yeah. I'm sorry. I think I'm wrong, but actually this one is not the last 5,000, but the first 5,000. So we will get from a 0 rows to 4,999 rows from our training data set, right? But this one is after, yeah, we will get the 55,000, the last 55,000 from the training data set. So it means if we have 60,000 rows, then the first 500 rows and the first 5,000 rows is for validation data set, and the last one, the last 55,000 rows, it's for training data set. So you can just type in this code. Yeah, this one is for getting the first 5,000 data from the training data set, and this one is the last 55,000, right? Because we have 60,000 training data set. Then you can just dividing by 255, like I mentioned before. I want to change the range from 0 to 255 into 0 to 1. Okay, then after that, yeah, you can just copying this code. Then we will create another code for y valid, and also y train. Okay, yeah, it's similar. So we can just change this one because we have a training data set, and in our training data set only have the also have the label, right? So this one is for getting the class. We don't need to divide it, this value to 255, because this one is the label, not the pixel value, right? Okay, so I think, yeah, we have created a validation data set. Okay, let me check this code first. Okay, let me check this code first. Then I want to print the xtrain shape. This one is the capital letter, xtrain.shape. So it means I want to know the shape of this training data set now, because I have, yeah, I have split this training data set, and I have give the 5,000 data set from the training data set into the validation data set. So it will be 55,000 times 20i times 20i, right? Okay, what about the y xtrain, and also what about the x valid? So the x valid will be 500, right? Okay, so I think we have correctly create the training, validation, and testing data set. So we will continue into the next code. Then after that, we need to change the shape of this variable. Why we should change the shape of this variable? Because if we use the TensorFlow, yeah, the TensorFlow, so the TensorFlow data, the TensorFlow for the image classification, we need to, yeah, because this one is the grayscale image. Okay, before I explain about the reshaping function, so I will just to, yeah, okay, let me type this code first. We use in matplotlib library. Matplotlib is for showing the image, right? Okay, I will try to print the first image in our validation data set. You can just using the plt.em show. Then I want to showing the first image. So it means the 0 of the x valid. X valid 0. It means I will get the first image from the validation data set, right? And don't forget to give another parameter, cmap equal gray. So it means because our image is a grayscale image. So as you can see right here, this one is 5, right? The 5 number. We know that the this one x valid with the index 0, it means we will get the first row or the first image in our x valid data set, right? So we know that this one is the shape of our validation data set. But if you want to use the deep learning model using the TensorFlow, we need to reshaping this. We need to reshaping this data set. Why? Because by default, our deep learning model using the TensorFlow, by default, it will classifying the color image. We know that the color image, we have another dimension after the 28, right? If we have 5,000 times 28 times 28 times 3, it means we have a 3 channel, right? But if we use the grayscale image, so we only have 1 channel. But by default, by default, the TensorFlow library only support for the grayscale, only support for the color image. But it doesn't matter. We can still use the grayscale image, but we need to reshaping this data set, this training and validation data set into 5,000 times 20x times 20x times 1. So we will give another 1 after 20x. So how to reshaping this data set? It's very easy. You can just use this code extrain equal x underscore train dot reshape. Then we will reshaping this one, xtrain. We will reshaping this one. We know that xtrain, xvalid, these two variables have the same dimension. But yeah, the first index is different because xtrain we have 55,000 and validation we have 5,000 for the first dimension. Yeah, the dimension in the first index, right? Yeah, we can just reshaping this one, xtrain. We want to reshaping this one into, let me print this variable first, xtrain. So we will change this dimension into 55,000, 28, 28, and 1. So we can just reshaping this one by using this code. We will give parameter as xtrain.shape 0. It means we will use 55,000. Xtrain.shape 0, right? Xtrain.shape 0. So it means we will get the 55,000. Yeah. Then what about the second and third parameter? You can just using 28, and 28 and also 1. So it means we will change this dimension into 55,000, 28, 28, and 1. Okay, let me print the xtrain shape. Yeah, 55,000, 28, 28, and 1. Yeah, like I mentioned before, because the tensor only support for the color image. Yeah, if we don't reshaping this one, we will not be able to use the TensorFlow or building the deep learning model for image classification. Okay, let me copy this code because we want to change the dimension of all variable, right? For the train, valid, this one is for valid, and test. We will change all of this dimension for this variable, right? So this one is lowercase x underscore test. Let me check this first. Yeah, x test and y test. Okay, we also change this value to valid and valid, and this one is for testing x. Okay, let me print all of this dimension: xtrain, xvalid, and also xtest. Okay, so we have 55,000 for training dataset, 5,000 for validation dataset, and also 10,000 for testing dataset. And we have changed all of this dimension into this form, right? Okay. So yeah, we will start to build our deep learning model. We have two ways to create a deep learning model. We can use a sequential library, and also we can use, wait a minute, my screen is freezing. Wait. Okay. Yeah. We can use two ways for building the deep learning model. So we will start from the easiest ways. The easiest way, it means we will use the sequential model. We can use sequential, and we can also use the Keras model. Okay, let me start to explain how to create a deep learning model using the easiest way, right? So we will import from the Keras model. So from Keras.models, we will import the sequential. So it means we will build a sequential model for CNN architecture. Import sequential. So it means we will build a CNN model using sequential library. Then after that, we will also import some library. We will import the dense, flatten. Why we should use dense, flatten, and conv2d? Because we will build CNN model. We know we have a CNN model, we have a convolution layer, and we also have a max pooling layer. So this one is for creating the deep learning model and this one is for creating a CNN model, right? We have a dense, we have flatten, we have conv2d, and we have also max pooling 2d. Remember, in CNN model, we have a convolutional layer and we also have the max pooling layer, right? Then we also have a dense layer. This one is for the layer after the flatten. This one is input layer, and this one is for, we can use this one is for creating the output and hidden layer. Dense, yeah, flatten is for converting the image into one-dimensional vector, because we know that if we put the feature into our ANN, we have to make sure that the input in a one-dimensional vector, right? Okay, let me continue my code first. So I will create a layer, right? So I will create another code cell. So I think we need to have a break. I know if we just focusing on the code, you will be boring. So I think it's better if we have to take a break around 5 minutes, and we will continue our class in 14:11. Okay. If you have any question, you can just typing in the chat box, right? Okay, let's continue our class. So there is a question from David Christopher. Excuse me, sir, can you repeat how to load MNIST dataset? Yeah, sure. So this one is for loading the dataset from the MNIST. So yeah, we load the dataset from the MNIST using from Keras the datasets import MNIST. Don't worry, I will share the video recording after this class. So, and I will also share our my notebook, yeah, in ULS after this. But actually, this one is for loading the dataset from Keras library. Yeah, MNIST dataset. Actually, there are another dataset inside the Keras dataset, but yeah, we can just use the MNIST for building an image classification model. Okay, there is also a question. Yeah, there is also a question from David. Sure, can it be reshape shape 0? Correct. Yeah, you can also use that one. Shape 0. It means we will get a 55,000, right? This one is 55,000, and this one is 28, and this one is 28, right? Yeah, we can use that one. We can also use the code from you, David Christopher. But why I don't give the number? I don't use shape. Yeah, because I believe that all of this data set has the same have the same resolution for the image, like 28 times 28. So I believe that all of our data set only have 28 times 28 pixel for the image, right? 28 times 28 image. But this one, the first dimension, it means it will be different between X valid, X train, Y valid, and Y train. Yeah, it has a different value for the first dimension. But for this one, 28 and 28, yeah, we can just use this one because, yeah, I honestly I lazy to type this by using the dimension of each shape. But yeah, it can also work by using your code, David. Okay, let me continue the code. So yeah, we have import some libraries from the Keras. Then we will start to build our CNN model. Before we build the CNN model, I will give the explanation for you for how what is the architecture in CNN. So remember, this one is the architecture for CNN CNN model, right? We have a convolution layer. We also have a max pooling layer if we use the max pooling, but we can also use average pooling. But in this image, we use the max pooling, right? So this one is the convolution layers plus pooling layers. And we also have the fully connected layer, and we also have a dense layer, right? Okay, this one is dense layer, and yeah, fully connected layer and dense layer. Actually, the fully connected layer, it means we will change the dimension of the image, the output of this convolutional and pooling layers, we will convert it into one-dimensional matrix or vector. Because our ANN model, this one is ANN, right? CNN, it means we have the convolution and pooling layers, additional layers for our ANN model. So it means convolution plus pooling layer, convolution layer plus pooling layer plus ANN, it means we have CNN model, right? So, okay, let me share the code again. So, okay, so we have import dense layer, flatten layer, conv 2D, and max pooling 2D. Like like I was mentioning before, this one and this one is the first layer in our CNN model, right? So we will start to build CNN model. by creating a convolution layer. The convolution layer first. So yeah, I will execute this code first because I haven't executed it. Okay, flatten. Oh, we need uppercase for the F character. Okay, then like was mentioned before, we can use sequential for building a deep learning model. So we will give the name of our model. This one model, it means we will build a variable that contain a deep learning model. Model equals sequential. So this one is the model. This one is the model, the variable that will bring the CNN model. Then after that, we will add some layer. Like I was mentioning before, we have to add the convolution layer because we built a CNN model, right? So in this one, we will add conv2d because we will give the convolution layer inside our model. Okay, let me share the slide again. So this one is the convolution layer, right? Convolution, it means we will extract the feature from our image, right? So this one is the convolution layer. Then because we have the convolution layer in CNN, then we need to add the conv2d layer inside our model. Then this one is 32. It means this one is the size or the number of the kernel. Okay, let me share the slide again. So this one is the number of the kernel. It depends in our need. Yeah, this one is the parameters that we can just change by ourselves. If we give the number of 32, it means we have 32 layers for the convolution layer. 32, it means we have 32 kernel, or we can just say it as a filters for extracting the feature from our image. So the number of the filter, it means if we give the 32 values, it means we have 32 filter in convolution layer. The number of the filter, or we can say it as a kernel. Yeah, kernel is filter is similar. If you take the digital image processing class, you know that the kernel or the filter, it means we have a small piece of the image for extracting the feature or for enhancing the image, right? Okay, then after that, we will go back to our code. Then, and the kernel size, we will give the number as 3 times 3. It means we have 3 times 3 filter. And how much the 3 times 3 filter? We have 32, right? Okay, let me say just a filter, right? Filter. We will not use the kernel, but filter. So, yeah, kernel and filter is similar, but if I don't want you to be confused, so I will say it as a filter. Then 3 times 3, it means we have 3 times 3 filter. 3 times 3 filter. And how much the 3 times 3? 32. Then the activation is ReLU. You know, remember, if we use the convolution layer in CNN, after we convolve, after we extract the feature from the image, then we will give the activation function of each pixel that have been extracted. Then remember, ReLU, it means the activation function. If the number, the extracted feature is more than or greater than 0, so we will not change the value. But if we have less than 0 pixel, then we set it as a 0, right? So it means the ReLU activation function. And the input shape, it depends on the image that we have, because we have a similar pixel value for our data set, not only training, but also testing and validation. We have a same dimension. So we don't need to reshaping all of our image, but we can just use this one as a 28 times 20x times 1. If you have a graphical image, if you have a color image, you can just change this value to 3. But we have a graphical image, like I was mentioning before, so we need to change the value to 1, right? Then after that, we also wait. We also give another parameter after the input shape. So I will give the parameter, the last parameter for padding. This one is the what is it called? The method for convolution layer. We have a padding. We set the padding as the same. So it means we will start the kernel to convolve the image from the left corner until the bottom corner, right bottom corner. Okay, the padding, it means, yeah, the method for convolving the image. Okay. Okay, we have created convolution layer inside our CNN model. So this one is the convolution layer. So what is this the layer? The next layer. The next layer is the max pooling layer. Remember, after convolution layer, we have to add the max pooling layer, right? So we will give another model dot add, then we will call max pooling to the, and the number of the pool size, it means, yeah, it's like the kernel size, yeah, 2 times 2. Okay, I will explain it in a second. 2 times 2, then strides equal 2 times 1. So it means this one is the, yeah, the parameter for pooling, max pooling. So okay, I will be sharing the slide again. So where is the slide? Wait, where is my slide? Okay, that's okay. I have a problem with my computer. I don't know why it's very lagging. Okay. Okay. We have a convolution layer and we also have the pooling layer, right? So this one is the convolution process, right? If we have the same padding, it means like this one. So we will start from the right top corner until the left bottom corner. So it means the padding is same. We will not use the filter outside our image, right? And we also have the pooling layer, right? The pooling layer, it means after the convolution process, we will get a new image, right? New extracted image. Then after that, we will get the maximum value of each 2 times 2 pixels. So it depends on the parameter that we set. Like I was mentioning before, we have we use the pool size equal to 2,2. It means we will use 2 times 2 pixel for getting the maximum value of each in this area. Then after that, the stride is 2,1. It means we will shifting this area one by one, then 1, 1, 1, 1, 1, then this one is 2. Why 2? Because we set the value 2,1. Okay, let me share my code again. So this one, I use the pool size equal 2 times 2. It means we will get the value of each 2 times 2 pixel from the image after the convolution process. Then the strides equal 2,1 is it means the step, yeah, the step of our pooling process. We use a two, it means we will step two rows, yeah, two rows and two rows, but one column, and one column. So let me share the slide again. So we move to the right one by one, right? This one, or this one is not 2,1, but this one is 2,2. The stride is 2,2 because we shifting this area two rows, two column, and also two rows. But if we use the strides equal 2,1, it means the pooling value and the pooling process will use the one column and also two rows for shifting the area to be for the max pooling process, right? Okay, yeah, it depends on the parameter that we set. Yeah, if we can just use we can just use 2,1 for strides and 2,2 for pooling size. Yeah, it's depends. It's just a parameter that we can just set, right? Okay, we can just use 2 times 2 for the pooling size and also 2 times 1 for strides parameter. Okay, let me continue my code. Then this one is for pooling layer, right? So I have created the pooling layer. Then after that, I will go into the flatten layer. So we can just use model.add flatten. Then the input shape is equal 28 times 20x. So why 20x times 20x? Okay, let me explain it in a second. Because actually this one, the input shape, it's from our previous layer. So this one have the output 28 times 20x, right? Yeah, if you use the convolution to the layer, so the input must be have a 3 dimension, right? But for the flatten, the input can be 2 dimension because the output for the max pooling layer is 2-dimensional matrix. Okay, so this one is the input layer. Then after that, I will give another layer. So this one is the hidden layer. I will give the number of the neuron inside that layer is 256, like this one. And the activation function, I will use ReLU activation function. And also for the second hidden layer, I will use maybe 128, 128 for the second hidden layer. Then after that, the last layer is the output layer. So my question is, what is the number of the neuron in our output layer? Anyone can just answer my question? I just want to check that you're still focusing in our class. Okay, what is the output layer? What is the number of our output layer? So let me share on the slide again. So this one is the, where is my, okay. So we are in this position, right? We are in this position, and this one is the output layer. So my question is, how many neuron in our output layers? Anyone can answer my question? And what kind of the activation function that we will be using? Anyone? Okay, Samuel Helin, thank you. 10. Why 10? Why 10 and why softmax? Samuel and Henry.
Because it gives outputs 0 until 9. Sir.
Okay, so the number of class, or the number of label, right? The number of the label that we want to classify is 10, right? From 0, 1, we want to classify 0, 1, 2, 3 until 9, right? We have 10 number from 0 to 9, right? because the label in our image dataset have a 10 labels, right? So the number of the neuron will be 10. And why we should use the softmax activation function, Henry?
Because it's the common one for multi-classification.
Okay, right, correct. So softmax activation functions, actually, I think that I have explained to you why we should use the softmax activation function, when we should use the softmax activation function, when we should use the sigmoid activation function. It's because we are working in the multi-class or multi-level classification problem. We have more than two. We have more than two levels in our problem, like 0 to 9. We have 10 levels. So the common one, yeah, it's true. The common one for classifying the multi-class classification problem is the softmax activation function. But if we have a binary classification, we can also use the sigmoid activation function or time h, yeah, because yeah, we have 1 and 0 value, 1 and 0 for the sigmoid activation function, and we also have -1 to 1, if I'm not mistaken, for the time h, yeah, time h activation function. So because we are working in the multi-class classification problem, then we should use the softmax activation function. But if we are working on the binary classification problem, it's like, detecting the cancer, we have only two label, right? Cancer or not cancer. Now we can use softmax and we can also use sigmoid activation function. Okay, then the last and the output layer, wait. So we are creating our output layer or the last layer in our model, right? Then we will give the activation, we will give the 10 neurons and the activation function, the type of the activation function, we will use softmax. Okay. Then we have created our model, right? So if we want to, if we want to get the information about this model, so I want to give the information summary of our model, so we can just use, okay, let me execute this code first. Then we can just use model.summary. It means we will get the summary of our model, the information, like this one. This one is the conv2d. It means we have a convolution layer, and the output shape will be 28 times 20x and times 32, because we have 32 layer. We have 32 filters, right? And the number of the parameters, why 328? Anyone can explain to me why? What is 320? Why we have 320? So this one is the output, right? The output from our convolutional layer. Okay, anyone can answer my question? Oh, wait, I have wait. It's actually this one. This one is the summary, right? So we have a 32, 320, right? 320. Okay. Anyone can explain to me why we have 320 for the input, right? So this one is the input and this one is the output. Okay. Anyone? No. So actually, this one, yeah, we can just skip this one because actually, honestly, I also forgot what is the why we have a 320 parameter for this input. So actually, let me check after this. But for the second layer, we have a max pooling layer. We have the output as a 14 times 27 and times 32. So we will be flattening this layer. 14 times 27 times 32, it means we have 12,096 output, right? Because this one is not a factor. Then we will flattening this layer, the output of this layer, then we have a 20,096 output, right? So this one is the output from this layer. And this one is the output of this layer will be the input for the next layer. We have 256 neuron. Yeah, we have a 256 neuron, right? Then we can just multiplying this output into with this neuron. So it means 296 times 256, we have 3,096,832 input, right? So this one is the input. Yeah, the input of this layer, right? This one times this one will be this one. And this one we have 128. This one is a number of neuron in this layer. So the input of this layer will be 32,896. So where this one? How can we get this value? It's because we have this one is the number of the neuron for the first hidden layer, and this one is the number of the neuron of this layer. So it means this one times this one. So let me check. Let me calculate. 256 times 120x. We have 32,768. So let me wait. Let me share all of my screen so you can see all of my screen. Okay. So this one, 256 times 128, we have 32,768. Yeah, it's different with this one. Why? Because we have not including the bias. Every neuron have a bias, right? So we can just adding with 128. So we will get 32,896. So it means each neuron will get will have the input and output, and the input is the number of the feature. If we have 100 feature, then we will use it as an input, right? But for one neuron, we have a bias. Yeah, if you take the machine learning course, if you learn about the logistic regression or linear regression, we have a bias value or intercept, right? The intercept value. So this one is from 256 times 128 plus 128. Okay. Then this one, 190, it means we have 128 times 10 plus 10. We have 1,290. Okay, so this one I still not get the answer why we have this value. I will check after this, right? Because this one is the input, right? The input, this one is the input for this layer, right? Okay, let me check this. Let me check after this. 256. Okay, this one will be the input for this layer, and this one will be the input for this layer, and this one must be the input for this convolution layer. Okay, Astri have the answer. I think the 320 depends on the parameters of the previous conv2d model. The first parameter is 32. When changed to 15, then the output will change to 150, because we have 32, right? 32. Okay, let me change this value ya to 15. Astri ya. So why we have 150? Why we should multiply with 10? So actually I have explained it in FGATTA course, but sorry, I forgot why we get this value. Okay. Okay. Juan, from what I found, parameter for the convolution layer is shape of a width filter and shape of width of the filter 3 times 3 ya. Shape of the width of filter times shape of the height of the filter. So we have 3 times 3 times the number of filters in the previous layer plus 1. So it means we have 3 times 3 ya. 3 times 3, we have 9, right? We have 9 times the number of filter. The number of filter is 32, right? Plus 1 or plus 1. So 3 times 3 equal 9 times the number of filters in the previous layer. So we have 33 ya. Okay, maybe Juan you can just typing the number in the chat box. So yeah, 3 times 3 and times what? Yeah, 3 times 3, 3 times 3, because this is the width and the height of the filter, times the number. Okay, 1 3 times 3 number of filter in the previous layer. Why we have 1, Juan?
I think it because we use the input layer is from a grayscale image, so it only has one channel. From according to what I found, the input layer is using 3 channels, and the number of filters in the previous layer that they use is 3, according to the input layer.
So let me check. So like this one, because we have 32 layer, right? Not 15 layer. I changed the layers, the number of the layers to 32. So if we have, okay, this one is 320, right? Okay, let me think about this. So 3 times 3, it means the size of the kernel, right? The filters. And 3 times 3 times 1, 1, yeah, and then, yeah, okay. 1 is the number of the channel, because we are working in the grayscale image. So why we should add 1, Juan, plus 1?
I'm not sure about that, sir. Sorry.
Okay. Okay, let me check in my previous video in FGATTS. Actually, I also record my explanation in FGATTS course. So after this, I will check it. Yeah, sometimes we forgot about the things. Yeah, it's normal. Okay, but so actually then for the max pooling and flatten, we have not the input from this one. Okay, let me check after this. So actually we have the summary of our model. Okay, let me share. Okay, let me continue my code. So this one I will just remove this cell. Okay. 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 We can also we can also draw the architecture not only in the table, because if we use the model the summary, we will drawing a table, but we can also drawing, it's like the architecture of this CNN model. So we can just use the library from Keras, from keras.utils.utils import plot underscore model. So this one is for drawing the architecture, not only the table. Okay, so we can drawing the architecture using this library. So we can just call the plot underscore model and it. Okay, my computer is so laggy. Okay, plot underscore model, then we put the parameter as model, then show shapes equal true. So it means we will showing the shapes of each layer, and the show, and the last one is the show layer names. We can also showing the layer names with show the layers, the layer names equal to. Okay. Let's execute this code. Then we will have the architecture, right? So like this one. This one is the convolution layer, and this one is the this one is the convolution layer. This one is not convolution layer, the input layer. Sorry, this one is the input layer. Then we have the convolution layer. The input of this convolution layer, like I was mentioning before, we have 28 times 20x times 1, because we have 28 times 28 image in a grayscale color. Then the output will be 28 times 28 times 32, because we have 32. We have 32 filters. Then after that, this output will be the input for the next layer. For the max pooling, after we doing the max pooling process, we will get a more, what is it called? More reducing size. Yeah, this one is reducing the size of our image from the previous layer, right? We have 20x times 20x, and we have, after we doing the max pooling process, we will have 14 times 27 times 32, because we still have 32 filters. Yeah, this one is from our previous layer, convolution layer. Then after that, we will flattening this layer. We'll make this layer to be a one-dimensional matrix or a vector. So this one is 14 times 27 times 32. Then if we multiplying this input, the output will be 12,096, right? Then after that, this one will be the input for the next layer, because we have 256 neurons. So the output from this layer will be 256. Then after that, this one will be the input for the next layer, right? And the output will be 128, because we set the number of the neuron of this layer 128, and this one is 256. Then we will have 128 for the input layer in our output layer, and the output will be 10, because we have 10 label, right? Okay, let me check this one. why we, I'm still curious, yeah, why we get the 320. Okay, input and will be the output, the parameters. Conv2d, this one is the conv2d input layer. Okay, let me check after this. Okay, so this one is for creating the model using sequential, right? This one is the sequential. But we can also create another model. Yeah, we can also create another model by using the, let me train this model first, because I just realized that now we still have around 1 hour, yeah, 1 hour for our class. Okay, I forgot to train this model, so let me train this model, right? Because like I was mentioning before, we are working in the supervised model because we are doing the classification problem. Okay, then we will compile this model.compile. Then we will set the loss function. Wait, my computer is so laggy. Okay. So we will use the loss function. We have a lot of loss function, right? Wait, it's very laggy on my computer. Okay, let me close my another application. Yes, I get an issue in my computer. I'm using the previous version of MacBook, yeah, MacBook Air 2020, and it has a big issue because it used the Intel processor, and the issue is if we push the computer or use this for multitasking, so it's very it faced the thermal throttling problem, because the fan of my computer cannot reducing the temperature of the processor, so the issue like this one. So okay, yeah, okay, let me continue the code. Let me close my another application. Okay, this one is not important. Okay, I will use the loss function because we are working in the classification problem, not regression problem. If we are working in the regression problem, we can use mean square error or mean square error or mean absolute error, and also we can use the R square for evaluating, evaluating the error, right? But in this problem, we will use the sparse categorical cross entropy, because we are working in the classification problem, not the regression problem. Sparse categorical cross entropy. Okay, and the optimizer, we can just use, maybe we can just try the SGD. We can also use the ADA grad and ADAM optimizer and stochastic gradient descent, because in this problem, in this model, I will use the optimizer as a stochastic gradient descent, and the matrix performance metric that I will be used is only accuracy. So the last parameter is the matrix equal accuracy. This one. Then yeah, we will compiling our model using the sparse categorical cross entropy loss function, and the optimizer we will be using stochastic gradient descent, and the matrix we will be using the accuracy, because on each epoch I want to see the loss value and also the accuracy value. Then after that we have compiled our model. Then after that we will train our model. Compiling, it doesn't mean we have trained our model, but only only compiling the model by using some parameters, right? Compiling is like we make the model ready to be trained, right? Then after that we will training our model. I will create a variable history. It means I want to save the value of each parameters, loss and accuracy, right? So this one and this one, I want to get the value, the loss value and the accuracy value for each epoch. Okay, then after that I will just type model.fit. Then I will give the parameter as xtrain and ytrain, because we will train our model using the training data set. And the number of epoch can just set to 20. So this one is the number of the epoch, right? How many our model will learn from our data set? 20. It means we will train our model 20 times. Okay, then the validation data, because I use train, test, and validate, like I was mentioned before. So I will use the validation data from the xvalid, right? Then also yvalid. So, okay, then let's compile this code. Okay, epoch use as. Then we can see that this one is the training process. We need to wait until the training process is finished, because we still we need a time, yeah. We need a time to training our model. So this one will train the model. 1719 is the number of the, what is it called? The batch, yeah, the batch value. So wait, yeah, we can see that the loss value and the accuracy, we hope that the loss value will be decreasing, right? But the accuracy value will be increasing, because if we set the epoch, yeah, the higher epoch, it means our model will train more in the same data set, right? I have not set the batch value, right? So actually this one is 1719. It means it's not the number of the data set. It's not the number of the training data set, but actually this one, it depends on the batch size, right? Like I was mentioning before, if we use the batch size, it means we will learn not one by one, but we will learn bunch of the data. But I don't set the batch value, so it means we will use the default batch. I don't know how many batch that we will use for each training, for each epoch, right? But I think if we have one, wait a minute, if we have 60,000, yeah, 60,000, sorry, 55,000. If we have 55,000 data set, so we can just dividing or multiplying, yeah. Wait a minute, I will share all my screen. I will open my calculator. If we have 55,000 training data set, then we have 1,719. It means the number of the batch. Okay, so I can conclude that the batch is 32. It's around 32. So it means every training process in one epoch will learn around 32 data, right? We have 55,000. So it doesn't mean that our model will learn it one by one, but our model will learn it 32 by 32, 32 and the next 32 and the next 32 until all of the training data set have been used for the training process. So it means 1,719, it means we use the 32 of the bit size. So the default value of the bit size is 32 because 55,000 time multiply by 32, it means we have around 1,718, 718.75, right? So it means we will have 32 bit size. Yeah, I think the training process is very time consuming, right? I don't know. Maybe it's because I use a lot of resource from the Google Colab, so the Google will limit, yeah, my. Okay, there is a suggestion from David to make the epoch process faster. Can change the runtime to GPU in runtime. Yeah, that was very helpful. But actually, I have run this code. Yeah, because we are working in the. Okay lah. Okay, I will change to the GPU accelerator because if we are working in the image classification problem, it is recommend for you to use the GPU because GPU has more cores than the CPU, right? Okay, let me run all of my code again. I hope that the training process will be faster than before. Okay. Can just wait until the training process is finished. Yeah, I think the training process faster than before, right? we need around 42, 42 seconds. 42 seconds for each epoch. You can just multiplying for 42 with the 20, it's around 800 seconds. It means it's around 10 minutes. Yeah. Okay. Yeah, it's okay. We will wait until the training process is finished. Then we will see the accuracy from our model for the training data set, right? Okay, you can just try by yourself in your Google Colab. So this one is the compiling process. We set the loss function with the sparse categorical cross entropy. For the classification problem, we should use cross entropy for calculating the loss value. And what about for the regression problem? Okay, let me check. I think it's not MSE or MAE. It is the performance metric for the regression problem. But okay, let me check the loss function for the regression problem. Regression. Okay, regression and classification. Okay, we also waiting the training process, so we can just, okay, there is a problem with the, okay. Mean square error, mean square error, mean square. Okay, I think if we use the regression problem, we, this one is the, okay, mean square error, mean square logarithmic error. Yeah, I think MSE, MAE for the loss function for the regression problem. But for the classification problem, because we are, the output of the classification problem is not the continuous number, but the discrete, the discrete value. It means we have a label. So we should use the multi-class cross entropy or sparse multi-class cross entropy loss and Kullback labeler divergence loss. I don't know. I have not heard about this loss function value, but yeah, you can see that because we are working in the multi-label classification problem, so we can use the sparse multi-class cross entropy loss. Okay, I think the training process is finished, and we can see that the accuracy for our training data set is around, it's up to 99%, right? So it's, I think it's very good for the training data set, but for the validation accuracy, we also get the accuracy up to 98%, right? So our model, I think, is good enough for the classifying the number in training data set. We have not tested this model, right? We also train our model and validate our model. We have not tested into the testing data set. Okay, let me share this only for this Google Colab. Then we will try to test our model. But before we test our model, we need to drawing the learning curve. So it means we will draw the graph for displaying the accuracy for each epoch. Yeah. Wait. Yeah, learning curve is very useful for the researcher to see the trend for the loss value and also the accuracy value for each epoch. So I recommend you to draw the learning curve. Okay, so how to draw the learning curve? So we have called the matplotlib, right? So we don't need to import it again. Then after that, we need to import the the pandas, import pandas spt. Then after that, we call the pt.data frame. We call the history, because this one is the history. It means, like I was mentioning before, the history will contain all of the value of all of the loss value for each epoch, right? Data frame history. Then after that, the plot with the fixed size equal 8,5. Okay. So this one is just the size of this the learning curve, right? Then we will also give the plt.create equal true. Then after that, we can also call the plt dot set y-lim. So it means we'll give the limit for the y-axis from 0 to 1 and plt.show. Okay. Pandas has no attribute data frame, so I think I change this one to F. Okay. So as you can see right here, this one is the loss value and the accuracy. The loss value, it means the blue one, it means the line of the loss value. Loss value for the training data set. We really hope that the loss value for the training data set will be decreasing. Yeah, will be decreasing when the epoch increasing. And also for the validation loss, we hope that our model will have the decreasing value for the validation loss, right? And the accuracy, we really hope when the epoch is increasing, we really hope that the accuracy and also the accuracy for the training data set and also the validation data set will be increasing too. So this one is the value or the graph of our learning curve. Yeah, we don't need the learning curve is very useful if we want to see that our model is overfitting or not. If our model is overfitting, then our validation loss will be increasing as the epoch increasing. So it means we need to stop the epoch. As you can see right here, I think that in this epoch, our validation loss is increasing. So I think it is better if we just stop, we just stop the epoch, we just stop the training process in this epoch. I don't know, it's still be a research how to set the best epoch. So from the reference that I read before, we need to stop the training process if the validation loss is start to increase. Okay. Then after that, we will try to, let me test our model using the testing data set. So I will give the variable results equal model.evaluate. So it means we will try to evaluate our model using the testing data set. And then after that, to execute this code, then we can see that we have around 98% of accuracy if we test our model using the testing dataset. Then after that, we can just drawing the confusion matrix for our model. So we can use the import numpy snp np and from sklearn dot matrix import confusion matrix, then classification report. So this one is for drawing the confusion matrix. Then after that, we will use the y predict. This one is for y predict. It means this one is for getting the label from the training dataset. Test. It's similar with the evaluate. So it means if you use the evaluate, we will only get the accuracy. We cannot draw the accuracy matrix or the confusion matrix using model evaluate. But if we use the model predict, so it means we can get the y predict. It means we can get the label from our model, the prediction label from our model. Okay, then after that we will use this one y predict equal np dot argmax. So this one is for getting the right label. We know that the softmax activation function, we have 10 neuron, right? Each neuron will represent the confidence value for each label. So it means if we have 90%, 90% for that this data is the 9 label. 90%, it means that we have 90% confidence that this data set, this image data set is a 9 label, 9 class. It's 9 class. But actually, if we summarize all of this probability from each neuron in softmax, because the output of the softmax activation function is from 0 to 1. If we sum, if we have summarized all of this output value in the softmax activation function, so we will get the 1 value or 100, right? So after that, we need to get the np.argmax y predict x is equal 1. So it means we will get the label that has the highest confidence, right? Like I was mentioning before. So each label, so if I just write the code, okay, let me continue my code first, then I will explain it in more detail. So we will use the cm equal confusion matrix. The parameter is y test and also y predict, and print cm. Okay, so this one is for getting the label that has the highest confidence value, right? Because the output of the softmax activation function, if we summarize all of this neuron, all of this output in the output layer, in the neuron in the output layer, if we summarize all of that value, so we will get the 1 value. So it means if we have a 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this one is the label that we have from 0 to 9. We have 10 label, right? And the output layer, in the output layer, each neuron in the output layer, like I was mentioning before, we use the softmax activation function. So if we summarize the probability, so for example, the data set is in the 2 labels. So it means the right label for our testing data set, it means, like for example, in this wait, 90%, the confidence level or 0.9 is we confidence that the neuron, yeah, the neuron in the output layer, which represent the the labels 2. So the model that confidence at 90%, the data set is the right label for this data set is 2. So it means we have a 90% of confidence, right, for this label. Then, for example, for the 3, 0, 0. So 0, 0. So let's assume, yeah, let's say that the 5 label we have 0.1 value, 0.1 confidence level, and the others labels will be 0. So it means each of these neuron in the output layer will have the output from 0 to 1. But if we sum all of this value, we will get the 1 value, right? So it means why we should use the np.argmax, because we need to get the label, the neuron, yeah, that has the highest confidence, right? Okay, then after that we can just execute this code. So we will have the confusion matrix. As you can see right here, we can just conclude that our model can predict, yeah, in a good way, predict correctly all of the testing data set, right? Okay, I think that was our discussion today. Maybe you have any question before I end this class. Okay, the time is we still have 20 minutes, yeah, for this class, but actually, yeah, it's enough. Maybe you have any question before I end this class. Oh yeah, for the midterm exam, I forgot to give the information about the midterm exam for the UTS, yeah. So you need to learn all of this material from week 1 to week 7 until the implementation of the deep learning model using TensorFlow and also using the Keras and also using Python. So you need to we will need to you need to learn all of this material course from week 1 to week 6. So you will work on the multiple choice question for the midterm exam. It's like your quiz, yeah. It's like your quiz. So you need to learn, yeah. You need to learn from the week 1 to week 7. Yeah. I also will share my code on the ULS after this. So if I don't want to forget about this one, so I will download this. And after that, I will upload on the ULS. Then you can just access my code. So I think that's all about our class today. If you don't have any question, so I think it's enough. I will end this class. Okay, thank you for your attention. I will end this meeting. Good afternoon. Okay, thank you.
Good afternoon. Thank you, sir.